Today we're going to continue with section 3.3 on the first derivative test. This time we're going to come at it from a different angle. We're going to analyze graphs and use the first derivative test. The homework for this section is 61 through 73 all and 85 through 89. So we need to remember a couple of things when we go to look at graphs. First off, we need to look at the graph and see if it's my original function or it's a graph of slope of the first derivative. Number two, we need to remember that the x values are the same for f and f prime. They don't change, the x values. Number three, let me scoot that up. On number three, I'm just talking about these different components. So for example, f of x, that's just a y output for a particular x, and that's for the original function. So you put in an x, you get out a y, and that creates that original function. And then the first derivative is we're taking the derivative of that function so we can find the slope at any point on this. And so this output, f prime of x, it is really the slope at a particular x. It's the slope at the tangent line at any point on f. And so if these values, if these outputs from my slope are positive, greater than 0, that means it's a positive slope. Those are positive y values for f prime. If my f prime of x happens to be negative numbers, which is what less than 0 means, then that means that this is a negative slope, the negative y value for f prime. So let's take a look at a graph. Sorry, I'm going to cover up things along the way. Let's analyze a graph. Please denote that this graph is of f prime. This is not the original function. This is just for particular x's. These are the y's. These are my slopes at different x's. That's what this is saying. So on my original function at 1, my slope is 2. At negative 3 on my original function, my slope is going to be at about negative 2. So again, all these y's are the slope at those x's on the original function f. So let's start talking about some things. So first off, I tell myself this is a graph of f prime of x. This is not the original function. Next, so this is not a negative, that's me just denoting things like this. So if f prime of x is greater than 0, in other words, my y's greater than 0, that's right here, right? Aren't all of these f prime of x, all my y's for these x's, aren't they all greater than 0? That means it's positive slope values, positive y values of f prime. So on the interval negative 2 to positive infinity, all of my slope or y values are positive. So over here, let's push this up. The next one, where f prime of x is less than 0, in other words, negative. Where are my y outputs on this graph? Because this is f of prime. These two things match. So what x values? Well, these x values, all these y's are negative. So which x values? From negative infinity all the way up till negative 2, my y outputs are all negative. For all of these x's. For all of these x's, my y's will be negative values. For all of these x's, my y's will be negative. Well, let's see if we can figure out where f prime of x equals 0. Well, where will the y output be 0? It will be at what value? at negative 2, right? At negative 2, my y is 0. What is this? This is a critical number, right? This is a critical number. So we learned in 3.1 how to find critical numbers. When the first derivative is set equal to 0, in other words, the slope is equal to 0. What's confusing is that this graph is of f prime, not of f. I'm going to go ahead and make a sign chart. I'm still using the idea of the first derivative. So I have myself a critical number. Again, where is f prime of x equal to 0? At the x value, negative 2. So that is my critical number. And so I have two test points. To the left of negative 2 is negative 3. To the right of negative 2, I chose 0, an easy value. And then I wanted to know what's happening with f prime on either side, whether it's negative or positive. And then from that, I can tell you about f, whether it's decreasing or increasing. And so all I have to do is look at the graph to get the minus or plus. I've actually already stated it here. On this side of negative 2, what are my y values on f prime? Well, this is f prime. My y values are all negative. On this side of negative 2, again, we'll write down negative 2 here. On this side of negative 2, this is where it's all positive. And I've already stated that over here. So then I can write my summing statement. Since f prime of x is changing from negative to positive at x equals negative 2, comma, then my original function f has a relative min at negative 2. Now, I don't have the function or the graph of the original f function, so I'm going to leave it like this generically. At negative 2, comma, f of negative 2. So if I had the function, I could go get the y. But I don't have it. So I'm done. I've analyzed this graph. Let's go analyze a second graph. Here's a second graph. Sorry, I'm going to cover things up here. So please notice that this graph also is of f prime. This is all slope. These are all slope values. For some x on my original function, the y output, all of these y values, is the slope at those x's. So as I denote what is going on, first off I tell myself that this graph is of f prime of x, not of f. Second, I want to know at what intervals is my f prime of x, or my y's on this function, the y's, greater than 0. Or in other words, where are the y's positive? Well, aren't the y's positive here and here? So the interval is from negative infinity up until negative 2, and from positive 2 to positive infinity. That is where all of those y outputs on f prime are positive. Let's do the same thing for negative. Where is f prime of x less than 0? In other words, where are these negative? At what interval on my graph? So between the x values negative 2 and 2, all of these y values are negative. In other words, all of the slopes are negative. So let me go ahead and hide this. And then the last question, where is f prime of x equal to 0? In other words, I'm trying to find my critical numbers, right? Critical numbers, when you set your first derivative equal to 0. So I just look at the graph. This is this point here, the y is 0. At this point here, the y is 0. So which x values are that? Are they? 2 and negative 2. Those are my critical numbers. So now we can proceed and do the sign chart. So the sign chart, my critical numbers are negative 2 and 2, and I can get all this information from over here and still from the graph. And so f prime, again, that is the graph of this, and I've already answered this. On the left side of negative 2, I have a test point, negative 3. In between is 0, and over here 3. But I'm not going to put it into any function. I don't have a function. I have the graph of slope. And so over here, my y outputs are positive. In between -2 and 2, all my y outputs are negative. And beyond 2, all of my y outputs are positive. In other words, my original function, which I don't even know what it looks like, is increasing here in this interval, decreasing in this interval, and increasing in this interval. Now I'm ready for my summation of my two statements. I have 2 because I have 2 critical numbers. So since f of x changes from positive to negative at x equals -2, comma, then my original function f has a relative max at -2, comma, f of -2. And then my second statement, since f prime of x, or my slope, changes from negative to positive at x equals 2, then f has a relative min at 2 f of 2. Next, last page. This is motion along a line, like our bug moving. I give you the position function, and then we can find the velocity function by taking the first derivative. So you have a few problems that are dealing with this. What they're going to ask you is they're going to give you the position function. You're supposed to find the velocity function. How do you do that? You take the first derivative. B, it wants you to find the interval when the particle is moving right. B, find the interval when the particle is moving left. D, find the time when the particle changes direction. In other words, from right to left or left to right. So, I guess I can just begin. If my position function that they give me is -t squared plus 8t plus 10, when I take the first derivative, which is the velocity function, is -2t plus 8. Okay, I've done part A. Part B is to find out what interval is my particle moving right. So what I have to remember is I'm in my velocity. And what does it mean? How can I tell from my velocity function when I'm moving right? And right means when my y outputs or my slopes are greater than 0. I have positive f prime of x values. So let's just take my velocity function and have it be greater than 0. What I'm wondering is what times will this output, this slope, be greater than 0? This velocity be greater than 0? So as I do the math, and don't forget when you divide or multiply by a negative on an inequality, you must flip the sign. So what this is saying is when my times are less than 4, my velocity is going to be greater than 0, because that's what I set this up originally. And if my outputs are positive, then that means I'm moving to the right. And so my interval is from 0 to 4, because time starts at 0. So it isn't from -infinity to 4, it's from 0 to 4. Well, I've done part B. I have found the interval when the particle moves right. Now let's find the interval when the particle moving left. And so left means that my velocity or my slope, whatever you want to call it, is less than 0. This has negative values. So what I'm really asking is, again, my first derivative, the velocity. What times of t will make my velocity have negative outputs? Negative means I'm traveling to the left. So again, I proceed with the same math. I remember to flip my inequality when I divide by a -2. And obviously that means the times are greater than 4. So from 4 to infinity, because time can go forever. So I've answered part B and C. D wants to know when the particle changed direction. Well, that's at the critical number, x equals 4. Particle changes direction from right to left. Thank you.